Let's investigate surface area. When do students learn surface area? Well, in 6th grade standards, it says that they will be able to represent three-dimensional figures using nets made up of rectangles and triangles and use the nets to find the surface area of these figures. Apply these techniques in the context of some real-world and mathematical problems. So first, let's look at visualizing and understanding what a net is. You can have three-dimensional prisms, and they're often represented using two-dimensional nets. A cube has 6 faces, 2 of which are called bases, and 4 of which are called lateral faces. In other words, faces that are not bases. Here's an example of a net opening and closing. You can click on the interactive and it will show you. You can click on the net and it will allow you to open and close the net. So you can see it in 2 dimensions and in 3 dimensions. So this was a cube. This is another cube just in a different net, but it still folds into a cube. There's more. You can see other patterns and see whether or not they fold into a cube. So think about what it is to say, what is surface area? What are examples of situations where surface area calculations are necessary? What do you think? Well, surface area is the area of the outer or the lateral surfaces of a three-dimensional shape. You can think of covering something with wrapping paper, or a label on a can. Maybe you need that surface area. So think of some other scenarios when you would need to know surface area. Let's review some vocabulary. What is a prism? What is a cylinder? So here's a picture of a prism. It's specifically a triangular prism in this case. And it says, what are the faces, bases, and edges? Well, the faces are the flat surfaces that you see. The bases are 2 faces that are parallel to each other and are congruent. And then the edges are where faces meet. A prism is a solid object with identical ends, flat faces, and the same cross-section all along its length. When we talk about cross-sections, we're talking about if we cut this in different places, it would look the same. There's no curves. A cylinder is not a prism. So think about drawing the shape on a piece of paper using straight lines and then extending it up from the sheet of paper. So what is a net of a three-dimensional object? You can see here the net is the two-dimensional representation of the three-dimensional object. There's a great activity on centimeter grid paper. You can cut out the shapes or you could just look at them on the paper. You find the area of each panel or each face, and you decide on what three-dimensional shape they make. So you could actually cut out the net along the outer edge and then fold this net into the three-dimensional shape. Be sure you can identify these things. On each one of these, they're all triangular prisms. I know that because the bases are triangle, because it's 2 that are identical and they're parallel and they're congruent to each other. What is this shape? This is definitely not a prism because I don't see 2 parallel congruent faces. If we cut this out and fold it up, all of these vertices would come up to a point. What is that three-dimensional shape called? Well, that's a square pyramid. So the base of the pyramid is a square. How about this one? Well, this is called a triangular pyramid. It also has a special name called a tetrahedron that we use because that's one of the Platonic solids. So, let's go back to triangular prisms. How could you determine the dimensions of the triangular prisms? Well, we can look at the surface area of these shapes. So here's a net. This would be a rectangular prism. You could try this activity. Here's two solids. Draw their nets and then count the squares to find the surface area. This is a very special rectangular prism called a cube. And then this is a rectangular prism. Do we need a formula for these things? I think with the nets you can do it without a formula. Some textbooks try to make formulas, and that's fine. And it's great for students if they know where the formulas come from. It's important that they know how to compute the surface area in the event they forget the formula. I did include some formulas here for some different objects. We were really mainly talking about prisms, but you can find the surface area of some other shapes, cylinders, cones, spheres, as well as pyramids. So if you wanted to try those, you could use these formulas. It's also fun to see if you can figure out where those formulas came from. Thanks for watching.